technology, and finally a bit on distribution and storage and the challenges that come with it. So first of all, Air Liquide is a world leader in gas technologies and services for industry and healthcare. So we provide a lot of medical gases, but we supply mainly industry, typically with air gases, oxygen, nitrogen, we have a lot of specialty gases, well gases, and Air Liquide is one of the largest producers of hydrogen as well. As of today, most of it coming from refining processes. Either via SMRs or technologies. I think we do operate 2 or 3 ATRs as well. But this is not what we're looking at in the future. To briefly show you, this is the overall hydrogen value chain, and Air Liquide is basically involved in all parts of that, either by rendering services or producing or working with potential or our customers to improve the application of hydrogen. The focus today, obviously, is on the liquid supply chain. And Air Liquide has more than 50 years of experience with liquid hydrogen, starting with some liquefaction installations that we have. The largest one that was until last year was in Germany, in France, sorry, with a 10 tons per day capacity. Since last year, we have started up in Nevada, a 30 ton per day production unit, which is serving mainly the mobility sector there. We have a lot of technology development as well. We are also supplying research and development institutions and projects like ITER. We develop our own turbines. We have a lot of experience in distribution, although you will see later that is still limited because the overall market volume is limited, so that all the solutions are rather on a, but it's not a lab scale, but it's not huge industrial scale. And the usages and the main reason why we're in that was space, because they are the main consumers today of liquid hydrogen because it's used as a propellant. The ongoing projects is something that we see that it's taking up speed slowly. Again, the focus is on mobility, but now on a wider range, more than just going up into space. That's what I meant. The West Coast liquefier just started up last year. We have signed a contract to build in South Korea a 90 ton per day liquefier, which is actually 3 times the 30 tons per day, more or less standard plant, because that's a challenge for the commercialization and industrialization, that you need to standardize these products, otherwise they become extremely expensive. We developed a new truck for the transport of liquid hydrogen, because that is another challenge, that you not just need to liquefy, you need to bring it to the point of use, which is not always on site. And you can see I've listed some of the R&D projects or development projects that we're working on, and the focus is strongly on aviation. That's where we see potentially the biggest market in the future, but we are also well aware that this will still take 10 years, put it like that. So around the world with Airbus a lot. Also, some of you might know the Valdez project. So we're there to support and supply loading and tanking infrastructure, and hoping to contribute to the development of a megawatt range fuel cell powertrain. So about what are we talking about? The liquefaction of hydrogen is a challenge. There's, besides what I mentioned, the economic challenges, there's also some technical challenges. So obviously you need deep cryogenics, so temperatures around 20 Kelvin. You have to ensure that you consider all safety aspects, because hydrogen has a huge flammable envelope. other media. It's extremely light, which means you need to be very tight. You have to consider the quantum mechanics. At this physical conditions, you have two states of hydrogen, which is the ortho and the para, and under ambient conditions, you have like 75% in the ortho state, and if you cool it down, it switches to the para, which is a slightly exothermic process, which is a bad thing if you have a liquid and you want to keep it liquid, because it produces boiling. And then you have a cold gas again that you need to handle in one way or another. And the other challenge is that on the fast-growing market, you need to keep up and you need to scale up. And that's another development work that you cannot just, as you will be aware, just make things easily bigger. But we understand it will be one of the major levers for decarbonization of industry and mobility. So liquefaction technology as of today, basically here, state of the art, what you have today. That's actually, it's standard products that you can buy more or less from the shelf. But the size, the quantities that you can handle are limited, and they will not be sufficient. And due to this, there's not many units around, so most of them are more or less handmade. And the focus, therefore, is on the investment cost. That in turn means that the efficiency or the energy demand is above 12 kilowatt hours per kilogram of hydrogen, and that is about 1/3 of the overall heating value of the hydrogen. So you have a huge loss. This is basically quite similar to what we see on the LNG market here, the liquefied methane. And in the liquefaction process and also in the regasification, there are energy losses. However, if we go to scaling up, we assume that we're not only optimizing the capex and economies of scale, but at one point it becomes more important to also focus on the efficiency to optimize the operating costs. Basically, there's two steps. First, a quick cooling and cold purification, because you need to remove other trace components that would liquefy